Hello, this is Mr. G, and we've got some math terms here for you to begin with today. The first one that I want to look at is the term perfect square. So one math definition that we should know from way back in our educational history is that of a square. And a square is a shape that has four sides and four 90-degree angles, and all of the sides have the same size. So when we have, say for instance, as in this diagram, one side of 3 and another side of 3, the area of that particular square is 3 times 3, or 9. So 9 becomes a perfect square because there are two digits that can be, there is a digit that can be multiplied by itself, and that will give us a number such as 9. So if we start, for instance, with the number 1, 1 times 1 is 1. 1 is the first perfect square. Our next number 2, whole number 2, 2 times 2 is 4. So 4 is the next perfect square. And the base of 4, or the root of 4, is 2. 1, 2, 3 times 3 is 9. And we can continue this process on to infinity. We'll do a few more. 1, 2, 3, 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. And we should be able to continue the pattern from there. So to define a perfect square, any number that has a root or a number that can be multiplied times itself to equal that original number is a perfect square. So if we're looking for the meaning of square root, we're basically going to turn that definition around that we just looked at of a perfect square. It is what's called an inverse operation. In other words, just like subtraction can undo addition, multiplication can be undone by division, perfect squares, or squaring a number, is undone by finding the square root of that number. So again, let's go to our number 9. And I know already that 9 is a perfect square. I want to find the square root of 9. So there is a symbol that we use when we are finding the square root of a number. And here's what that symbol looks like. Kind of like a division sign, only it's got a little bit of a tail on the front end of it. And when we see that symbol there, we are dividing the number, or we are looking for the number we can divide 9 by that will give us the same answer for the quotient. So 9 divided by 3 is 3. So the square root of 9 is equal to 3. Well, what about numbers that are not perfect squares? So I'm going to start by drawing or writing our list of perfect squares like we had before. 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. And 7 times 7 is 49. So we'll stop right there for a moment. So what if I wanted to find the square root of a number like 14? How would I do that? Well, for one thing, I know it's not a perfect square, so I'm not going to get a whole number answer. So what I'm going to do in this case is just give an estimate of what my answer might be. Okay, so take a look at the number 14, and if we look on a number line, 14 is going to fall between 9 and 16. So it's going to be closer to 16 than it is to 9. So I can say that my square root of 14 is going to be between, it's going to be, square root of 9 is less than 14, and the square root of 16 is greater than 14. And since my 14 is closer to 16 than it is to 9, I'm going to say my answer is closer to 4, so maybe approximately 3.8. And here you can see when I take a calculator and multiply that out, I'm a little over my mark, but pretty close. So 3.8 times 3.8 is 14.44, or 14 and 44 hundredths. So that gives me a pretty close estimation. Well, what about the square root of fractions? So if I'm looking at the square root of a fraction, basically I'm still asking myself what number times itself will give me that answer as a fraction. Well, in this case it works out very well because 4 is a perfect square. And my numerator now is the square root of 4, or 2. And 25 is a perfect square. So in this case, 5 times 5 gives me 25. So finding the square root of a fraction with perfect squares for the numerator and the denominator, all I have to do is find the square root of the numerator and put that over the square root of the denominator, because 2/5, let's move this up here, 2/5 times 2/5 is going to give me my 4/25.